As an astronomer, I'd always wondered when the news would reach me, and as it turned out, it was sitting on my kitchen doorstep with my feet out of the porch in the August sunshine in the strangest of years, 2020, when the call finally came through. The voice on the other end of the phone was Dr. Chris Lintott, an old Sky at Night colleague of mine, now cosmologist at Cardiff University. And what he said may have changed my view of the universe forever. Chris, on the other end of the phone, said, well, it could be Venusians. He was ringing with the news of a discovery made by his colleague Jane Greaves, also at Cardiff, of a chemical called phosphine, found in the atmosphere of Venus. And phosphine is a simple molecule. It's nothing more than a phosphorus atom with 3 hydrogens attached. But it's exciting because on Earth, it's only produced by life. It's only produced by artificial processes that we use in factories, or it's produced by animals. A particular rich source is our penguins, in what I've been told by Gresham to describe as their guano, their droppings. And in fact, this has been used to spot penguins from space. So this is a satellite picture of part of the Antarctic Peninsula, courtesy of the British Antarctic Survey and the European Space Agency, and the little black markings you can see labelled there, let's just say, indicate the presence of lots of penguins. So Jane's discovery of phosphine in the Venusian atmosphere may have indicated the presence of small Venusian penguins flying around in the atmosphere. More generally, it's a biomarker, a biosignature to some, a chemical which, when we see it, we think indicates the presence of life. And finding phosphine, therefore, anywhere in the universe, but anywhere in the solar system, would have come as a surprise. The fact it was Venus, a world so inhospitable that if you landed and stepped out of your spacecraft, you'd be crushed, dissolved, suffocate, and boiled, all within the space of a few minutes, was really surprising. We have explored the surface of Venus. This picture was sent back by the Venera 9 probe, a Soviet probe that touched down 48 years ago this weekend, and lasted for a whole 53 minutes on the surface before melting. But it did send back this one picture. But it does indicate how inhospitable Venus is. The planet is roughly the same size as Earth, but it has this thick atmosphere, thick acidic atmosphere, which makes it a very unpleasant place indeed. So how and why had Jane and co. looked for phosphine on Venus? Well, it started off really as a point of principle. People have talked, as I'll get onto in a bit, of looking for biosignatures, for trying to detect the signs of life on distant planets. And so, in a kind of visionary way, Jane and co. thought they should look nearby as well to show that the telescopes could do this. And the telescopes you use to look for phosphine or any other molecule aren't optical telescopes. They don't involve mirrors. They look rather odd. This is the James Clerk Maxwell telescope, JCMT, high up on the summit of Mauna Kea, the central volcano, hopefully dormant, on the big island of Hawaii, a sacred site to native Hawaiians and home to some of the best observing on the planet. Inside this structure, there's a 15-meter radio dish. It's protected from the elements by this shield, which, according to publicity on their website, is the world's second largest piece of Gore-Tex. If anyone knows where the largest piece is, I've tried looking and I don't know. So one day somebody's going to come up after a lecture and tell me. But this is a radio dish attuned to the kind of frequencies that your microwave oven uses. It's very short-wave radio, what the astronomers call sub-millimeter. And that's not a coincidence. Your microwave bombards your food with radiation at a frequency that makes water vibrate. That's how it heats. And so lots of small molecules vibrate at these frequencies. And so by tuning our radio telescopes to them, we can detect all sorts of things in the cosmos. That's also, incidentally, why this thing's on top of a mountain. It needs to be up above most of the Earth's atmosphere. You need to be above the water in the atmosphere. All that you detect is our own planet. I myself once spent a happy couple of days making an independent discovery of ozone in the Earth's atmosphere by accident at the JCMT. There was also a telescope called ALMA, which we'll come to in a sec, in Chile, which backed up the observation. So Jane had 2 sets of telescopes which had detected this molecule. Now, it's a difficult measurement. There's not much phosphine. And Venus itself is really bright at these wavelengths. So it's like trying to stargaze while looking at a stadium floodlight. But with careful processing, after a couple of years, Jane and her team were able to pull out the signature of this thing. And actually, they could even work out where in the atmosphere the phosphine was, based on the signature that they were seeing. And here it gets really interesting, because it turns out that it's not distributed throughout the atmosphere, but it's in a layer high above the Venusian surface, in the very upper layers of the atmosphere of the planet. And if you ask what the conditions are like at that height above the surface, they're much more hospitable. They're about the same atmospheric pressure as we have at sea level on Earth, and the temperature is about the same as a British summer's day, so about 15 degrees centigrade, something like that. I guess that joke's slightly out of date these days, but anyway, you get the idea. It is still acidic, and acid is bad news, we think, for life. A point demonstrated in the Sky at Night program that we made by chemist William Baines, one of Jane's team, who took great delight. Chemists are always delighted to pour acid on things, I find. And he demonstrated that acid was bad for life by pouring it on toast and, for some reason, mushy peas. I'm not quite sure why those things, but they definitely shriveled alarmingly. So, though this is an acidic environment, high in the atmosphere, it might be a home for life that we weren't expecting amongst the clouds of Venus. And so that gives you this rather romantic story, I think, about this little colony of presumably not penguins, but acid-resistant bacteria. Venus, when it formed 4.8 billion years ago, along with the Earth, may have been a temperate world. It may have had a climate close to, if not quite as mild as ours. And you can imagine that if life is easy to get started in the universe, then that early Venus would have been a world rich in all sorts of flora and fauna, just as life on the Earth got started really quickly. And then these bacteria that maybe Jane had found are sort of the last vestiges of an old civilization clinging on in the last habitable part of a planet that had dramatically changed over the last 4 billion years. Venus has suffered from an extreme greenhouse effect. Its atmosphere has thickened, the water, if there ever was any on the planet, has disappeared, and we've ended up with the hellhole that it is today. I'm going to try and be rude about every single planet, so that's Venus ticked off. This result wasn't met with glee and excitement from everyone. People were careful not to say we had found life, just that it was a biosignature. And problems propped up pretty quickly. ALMA, the other telescope that Jane and co had used, looks like this. It's an amazing place. It's a series of dishes high on a plateau above the Chilean Andes. It's the most otherworldly place I've ever been. It's so high that lack of oxygen is a problem for working on the site, to the extent that these dishes, which are 12 meters across, if anything goes wrong, they're actually picked up and taken down the mountain so that the engineers can work on them with a clear head, because trying to do anything at altitude is difficult. It's a series of dishes where you combine the radiation from each of them to give the impression of a much larger, more sensitive telescope. And it turned out, because of the scrutiny that this phosphine discovery got, that there was an error in the software. And so it's not clear what to make of the ALMA results. It's possible that the second telescope, this confirmation of phosphine, was an error. It might just be a software glitch. And then astronomers used a telescope called Sophia, which is a remarkable thing. It's just been decommissioned, actually, but this is a 747 with a hole cut in the end. And in there's a 2.5 meter mirror, a telescope that could observe these submillimeter wavelengths. And it's an amazing thing. I managed to fly on Sophia, and the telescope is kept stable while the plane jostles around. And so while you're inside, you see the end of the telescope doing this. You think, how on earth is that pointing at anything? And then you realize it's not the telescope that's moving, it's you as you go through the turbulence. And you point the telescope by moving the plane. So you fly these quite strange routes over the Californian coast. It was great. But they had a look for phosphine in Venus and found absolutely nothing. And so most people thought that this result was going away. That's not too surprising if you think about Venus as an inhospitable place. The landscape of Venus is dramatic. This is exaggerated in the vertical direction 10 times, but it shows Mat Mons, a giant volcano on the Venusian surface, seen from a perspective as if you were 2 miles up. This is actually radar data from a satellite called Magellan that orbited the planet that you're seeing here. And this is a 3 mile high volcano, 5 miles above sea level. And wherever you look on the Venusian surface, you see signs of this sort of volcanic activity. And we even think the volcanoes on the surface are active. We found good evidence for this recently when an astronomer called Robert Herrick, who's actually working on a probe called Veritas that will go to Venus soon, looked for changes on the Venusian surface by comparing images that were taken many months apart. These are 2 images at the same place, taken 8 months apart. And you can see there's this difference. This main vent hasn't changed, but there's now this bright area to the right that's appeared. And this thing at the bottom, this other crater, has got larger. And the contention is that this is volcanic activity observed on the surface of another world. My other favourite thing about this discovery is that Herrick was interviewed and asked how he'd found time to look through so much of the data to try and find these quite subtle changes. And he explained that this is what he did when he was on Zoom calls and his colleagues were boring him. So you can put that time to use, it turns out. So we have a story where phosphine, maybe the detection was mistaken. I've just wasted the first 15 minutes of the talk telling you about something that doesn't exist, except that there's other evidence around. People went back into the archives and found data from this thing. This is Pioneer Venus, an American probe that dropped 4 separate probes through the Venusian clouds in 1978. One of those probes had on board a mass spectrometer, an instrument that can weigh the molecules that it encounters. So you don't get a label, but you get a weight for each molecule, and then you can go and match that to things you think are there. And it turned out at just the right height above the surface to match the observations, there was this previously unnoticed signal of pH3 of phosphine. So this probe had seen what Jane would see many years later. And her team have been back, used JCMT again, and confirmed the detection. So there really is phosphine in the atmosphere of Venus, I think. Not everyone agrees, but I'm right. And so is Jane. And it turns out Sophia, by the way, the aeroplane telescope, didn't see anything because the amount of phosphine changes over the course of a day. So Jane had always looked, by coincidence, in the morning, the Venusian morning. Sophia had looked in the evening. And so sunlight affects the chemistry, and we have a daily cycle. Is it life? Probably not. Could be. It's a biosignature on Earth. It's more likely, I think, that we don't understand the chemistry of the Venusian atmosphere. But people are working on that now to try and determine whether there really is life sitting in the clouds of Venus. It's fun to think that there might be. Even if it turns out not to be life, I think the phosphine saga tells us 2 things. One has grand implications for our view of the universe, and that's that we're building telescopes now. This is a shot of a recent shot of what will become the dome of the European Extremely Large Telescope. It's the successor to the Very Large Telescope. It's a project originally known as OWL, because it was going to be the Overwhelmingly Large Telescope, but we can't afford overwhelming, but we can afford extremely large telescopes. So this will have a mirror 39 meters across, and the dome is the size of a football stadium. And this will see first light in a few years' time, and one of the reasons we're building it is so that we can look at planets around distant stars, measure their atmospheres, and try and conclude from those measurements whether there are biosignatures there, whether there are signs of life. The problem is that if we can't even get our facts straight and can't even work out what's going on in our nearest neighbour of a planet, trying to do this on a distant star is going to be very, very difficult. I'll have more to say about that in a couple of lectures' time. The other thing is that contemplating life, even being able to contemplate life on Venus, makes a remarkable change in how we think about the habitability of the worlds in our solar system. Our solar system is a remarkably diverse place. We have everything from giant gas planets like Jupiter, all the way down to small rocks, asteroids named after luminaries like the Beatles or Frank Zappa, or there's one named after me. It shows you how many rocks there are if they're naming them after random astronomers. But if we look at the long history of people thinking about these things, the original assertion was that in the 18th and 19th century was that surely all of these worlds would be habited. William Herschel, the great observer I talked about a bit in the last lecture, even went so far as to believe that the sun, which he saw as a planet, it was a world with a landscape, must therefore be inhabited, and Solarians would cavort on its surface. Now, that's not true. If you learn nothing else today, the sun does not have aliens living on it as far as we know. But almost everything else that was seen in the solar system, any mysterious phenomena, could be attributed to life. So going back to Venus, when you see a crescent Venus in the sky, and our view at the minute in the morning sky is not so different from this, on the dark side of the planet, you sometimes see what's known as the ashen light, or rather observers have recorded the ashen light. It's this glow that appears to come on the dark side. How do we explain it? Well, clearly it's the campfires of a Venusian civilization. In particular, there was a wonderful period where people thought Venus would have canals or channels of soda water, carbonated for your pleasure. So you can imagine a nice evening by your soda water canal with a campfire and your favorite Venusians. Mars, of course, is obviously inhabited. My favorite argument for life on Mars was made most forcefully by Ernst Öpik, Lembit Öpik's grandfather, and an Estonian astronomer, who made the following argument. Mars has these dark patches that you see through telescopes. Even a small telescope with a bit of squinting and a bit of belief will show you that Mars has these regular patterns of dark markings. But sometimes, as in 2001, a dust storm will blow up, put enough dust into the atmosphere that all the markings on the surface of the planet are obscured. This happens every few years. You may remember such a dust storm from the film The Martian, where it causes trouble. But after a time, the same markings reappear. There's an obvious explanation. These are plants. They grow back through the dust that's deposited on them. That was Öpik's theory. It's not true. These are actually high areas, and we know that the wind blows things off. But it was natural 100 years ago to argue that this was a sign of life. And of course, Mars is where Martians come from. It was often believed to be the home of intelligent life. And in particular, at the end of the 19th century, there was a fad for producing maps like this one of the Martian surface that show these long linear features, which were known in English as canals. A slight mistranslation of Schiaparelli, who was an Italian observer who was the first to report them. He called them canali in Italian, which is channels, but doesn't have the implication that aliens have dug them out. But English-speaking astronomers, these were clearly channels, and there was a fad for looking ever closer at Mars and seeing the complexity of this network develop. Over time, people reported that what had seemed to be individual canals had doubled or even tripled up. And this was taken to be the expansion of the canal network by Martians bringing water from their polar caps down to the equatorial regions. Now, the slightly sad fact is that not everyone could see the canals. They were particularly spotted by observers at Mars Hill, the big American observatory in Flagstaff, Arizona, that was established by Percival Lowell, a businessman and philanthropist, to look for life on Mars. And there are various confused accounts of European astronomers and British astronomers who can't see these things, and arguments in the journals of the time by people pointing out that if you can't see them, then it's your fault. You clearly don't have a good enough telescope or good enough eyes. The canals are illusionary. For years, the explanation was that it was an optical effect, that people were seeing craters that were just out of vision, and then your brain joins them up into a line. It turns out even that's not true. They don't really trace any particular features. People were seeing what they wanted to see on the Martian surface. And as people thought seriously about conditions on Mars, a smaller planet than the Earth, one with a very thin atmosphere, it became clear that at least our kind of life couldn't survive on the surface. Strangely, it was Alfred Russel Wallace, who you might know from stories about Darwin and evolution, who was the great popularizer of this. He wrote a book in 1907 called Is Mars Habitable? Which is an excellent example of the rule that if a title has a question in it, the answer's always no. He showed that the atmosphere was so thin that you couldn't have liquid water on the surface. If you can't have liquid water on the surface, you can't have our kind of life. So that was 1907. The argument went on a little bit. I really like the example of a prize, the Prix Guzman, given by the French Academy at the start of the 20th century, set up to encourage people to think about life in the solar system and in the universe. And the Academy set the rules. They said that they would give 100,000 francs to the first person to communicate with a celestial body and receive a response. So you've got to get an answer back. You can't just go and shout at the moon. That's cheating. But in the rules for the prize, they exclude Mars because it's too easy. Everyone knows that Mars is inhabited. And people had made serious propositions to do things like build giant mirrors. And the idea was that you would focus light on the Martian desert and you could write words in the sand. And then we would expect the Martians to respond by carving words into the Sahara. How they'd know to aim for the Sahara and not, I don't know, Western Europe, I'm not sure. But people really believed this was true. There's also the Prix Guzman, the prize story ends slightly sheepishly, by the way, 69 years later, when there's not much left of 100,000 francs after what the first half of the 20th century's economics did to inflation and so on. But they do give the prize, basically to get it off the desk, in 1969 to the Apollo 11 astronauts. Because after all, they'd communicated with a celestial body and received a response. So that's that. So we can close the chapter and move on. So now I've mentioned the space age. There was still this idea that, maybe we wouldn't have Martians, but when we're visiting Venus and Mars, there was a hope that we might be seeing at least Martian bacteria, simple life or something like that. Venus, we've already seen, proved to be inhospitable. Mars, from the time the first Mariner 4 probe got to Mars and showed essentially a barren rock with craters on it, was also a disappointment. In the 1970s, the Viking landers, which can still claim to be, I think, the spacecraft with probably the most sophisticated set of chemical experiments ever to land on the surface of a planet, took samples, as seen in this glorious painting, took them on board and ran tests designed explicitly to test for life. And at the time, the results were reported as negative. Since then, there have been a minority view that the tests were a bit more ambiguous. I think the ambiguous results can be explained by the later detection of a chemical called perchlorate in the Martian soil, which makes it alkali, which I'm told is good for growing asparagus. So never mind the Martian and potatoes, you can do asparagus on Mars. But no sign of life. And though the missions of the 60s and 70s taught us a great deal and took beautiful pictures of the planet, mainly there was a sort of sense of failure, I think, that this great goal of finding life in the solar system hadn't succeeded. And Viking, if you talk to people who do space policy and think about which probes we should send where, Viking was seen as this disaster because they really promoted the idea that it was going to be a test for life. And then they tested for life and there wasn't any. And Congress and other funders concluded that therefore we didn't need to go back to Mars. And we didn't for a very long, long while. The next probe following the Vikings in the 70s to land on the Martian surface was the rather adorable Pathfinder with the Sojourner rover, which is basically a tea tray on 6 wheels, which landed in 97, much later, and following a new approach. So the goal of Sojourner and Pathfinder and the missions that followed was still to look for life, but they're going to do it in stages. So rather than just test for life, we're now exploring Mars to see if we can find the conditions for life. So that means finding water. It means finding what biochemists wonderfully call SNOPs, which is carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, the atomic species which make up organic chemistry. So you need to make sure that SNOPs are present. I do think it sounds like a drink. Like you get a small glass of schnapps in some Eastern European bar and you forget the next 2 days, that sort of thing. But this showed we could go back to Mars, and then the following missions revolutionized the story that we tell about Mars, so that we're not talking about this barren rock anymore. In particular, twin robot geologists, Spirit and Opportunity, which landed in 2004, just after the ill-fated British Beagle probe got to the surface but didn't quite manage to phone home. Spirit and Opportunity sent back amazing pictures like this one. This is a place called Winter Haven, where Spirit spent its first winter, Martian winter, surviving temperatures lower than minus 100 degrees centigrade. But these two rovers worked brilliantly. They were supposed to last for 90 days each. Spirit lasted for just over 6 years before it got stuck in a sand trap. Opportunity went on to break the record for the furthest distance traveled on a celestial body, traveling 28 miles in a mission that lasted nearly 15 years. More than that, here's an Opportunity photo, which is just beautiful. This is a place called Victoria Crater. More importantly than just their longevity, both probes showed us that Mars clearly had once been a wet world. There's all sorts of evidence for this, based on the fact that they were traveling across things that looked like river deltas and old watercourses, but also from close-up views of things like this. These are Martian blueberries, concretions of hematite, a mineral that forms in the presence of water. And so the fact that these things exist tell you that this mineralogy was established when Mars was wet. And we think that perhaps for the first billion years of its history, Mars was a wet world. It had oceans, it had lakes, it had rivers. Possibly some of those places were long-lived. And we've tried to understand what changed. Why Mars went from being a verdant oasis to the desert planet that it is today. And one answer is that it's just small. So it only has a thin atmosphere, and that atmosphere will have been lost gradually to outer space, stripped away by the solar wind, the particles that come from the sun. And so whereas Earth, with a magnetic field that protects us to some extent, Mars has only a very, very weak magnetic field, and the fact that it has a weaker gravity means it's managed to lose most of its water. Now, some of it's still there. There are those polar ice caps that shrink and grow with the seasons. There is a water component to them. And we now think there might be an enormous reservoir of subsurface ice as well, underneath the surface, protected by the Martian soil, detected by radar soundings from the European Mars Express spacecraft and by American satellites since. So maybe under the surface, protected from the solar radiation, maybe there's a place where life clings on in Mars as well. We're now at the point where people are confident enough that they want to go back, drill down, and start testing for life directly again. The European Franklin rover, which is sitting ready for launch, but delayed because cooperation with Russia, who was supposed to launch the thing, is now unthinkable, will do that experiment. It will drill into the ground and test in at least one place for life. Maybe we'll have to wait until samples on Mars are now brought back to Earth, something that people are planning to do, and so that we can test in earthly laboratories for signs of life. We can also, like we do on Venus, think about chemical signs of life. This is the Curiosity rover. This is just a brilliant selfie. It's a combination of lots of images. It's not that somebody hopped off the rover and turned around to take a picture, I promise. Curiosity, which was a follow-on rover following Spirit and Opportunity, has detected what I'm told by Gresham I should describe as burps of methane coming from underneath the surface. So it's happily trundling along and suddenly there's a cloud of methane, like walking behind the wrong end of a cow, I suppose, or something like that. Now, I'm not saying that there are small cows on Mars, any more than I'm saying there are penguins on Venus. But possibly This indicates activity, either volcanic activity on a world that we think is geologically inactive, or bacterial activity under the surface. But it's a big mystery because missions from orbit don't see the methane. And so there's a disagreement between what's measured on the ground and what's measured in orbit. But it's possible that we're measuring at different times of day, that the missions in orbit are looking during the day and Curiosity is there at night. And so we need to have a think about exactly what we're measuring. But there is at least the possibility of a biosignature on Mars. Now, I mentioned there was this long hiatus between Martian missions, between Viking in the 70s and the rovers that started in the late 90s. And during much of that time, we were focusing on the outer solar system, sending 2 Pioneer probes, Pioneer 10 and 11, and then the 2 Voyager probes to complete a grand tour of our solar system's giant planets, Jupiter, Saturn, and then the ice giants, Uranus and Neptune. These are beautiful places to be, of course, in their own right. I'm a big fan of images currently being sent back from Jupiter by the Juno probe, which orbits in this elliptical orbit and every 53 days swings close to the cloud tops of the planet and sends back pictures like this. This is the Great Red Spot, a storm 3 times the size of the Earth, which has been active, we think, for at least 300 years and perhaps longer. Also in this image, which I really like, is this spot here. This is an image from 2020, and this is known as Clyde's Spot, after an amateur astronomer in South Africa, Clyde Foster, who spotted it in his telescope before anyone else had seen it. We still rely on amateur astronomers to monitor the weather in the giant planets for us, but it's a beautiful, beautiful image. I actually just mentioned, as I'm mentioning amateur astronomers, I couldn't resist showing this from Damien Peach. This is with a small telescope taken from the UK just a couple of weeks ago. But you can really see the detail on Jupiter's atmosphere. And what you're seeing here are cloud tops. You're seeing storms and bands sculpted by winds that whirl around the center of this gaseous planet. We actually found out a little more about the winds recently. This is an image from JWST, our newest space telescope. And that central band, the colors are off because this is an infrared image that we've tuned to slightly longer wavelengths. That central band is a jet stream that's moving at more than 500 kilometers an hour. So about twice the speed of the Earth's jet streams. And trying to understand how this complex atmosphere behaves, how it interacts, and how it produces the features that we see is a good test of our understanding of climate and our ability to do atmospheric modeling of the universe, of planets like the Earth elsewhere. But unexpectedly, the missions to Jupiter and to Saturn became part of this grand story of the creation of life, or the search for life in the universe. Not on the planets themselves, though Carl Sagan speculated about hydrogen-breathing jellyfish and whales in the atmosphere of Jupiter, so if you want to go that far, you can. But actually on the moons, which turn out to be fascinating places. The red stripe at the top and bottom of this image is real. Those are the northern and southern lights on Jupiter, the aurorae, like those that we see on the Earth. They're caused, and they're spectacular in Jupiter, because of the presence nearby of the moon Io. This is a Voyager image, the first one taken of the moon, actually. This is a moon that was discovered by Galileo, but studied close up by these spacecraft. And you can see there's that plume off to the left there. That's a volcano that's erupting. It's actually a volcano called Loki, and in the middle you've got Pele as well. These are spectacular features. This is Io seen by the Galileo spacecraft. And the flare that's in the middle here, Prometheus, seems to have been erupting for at least 30 years. Io is the most volcanic place in the solar system, and the material that it throws up end up caught by Jupiter's magnetic field, hit the atmosphere, and create what must be spectacular displays of the northern lights. The other big moons of Jupiter have a different story to tell. This is Europa, a recent image from Juno, in true color. So this is what it would look like to be in orbit around Europa. And you can see that it has this smooth icy surface. It is, in fact, water ice. And you can see that there are very few craters on this surface. And that's important. The number of craters on a solar system surface tells you how old it is. The more craters you've got, the more meteorites have hit you. The more meteorites have hit you, the longer you've been sitting there out there in space. And so the fact that this is smooth tells us this is a fresh surface that gets resurfaced every so often. Results from the last couple of weeks from JWST tell us that that surface, this water ice, has salt in it, and a bit of carbon dioxide frozen onto the surface as well. So wherever this water is coming from and freezing onto the surface, it has a salty component, and it's also got some carbon in it. We're getting to the schnapps that we need to create life. Our assumption is that this is an ice shell with a liquid water core, so that within this moon, there's an ocean, a salty ocean, that we can imagine as a potential habitat. This turns out to be a common way of building things in the outer solar system. The next moon out, Ganymede, and perhaps even Callisto, the next big moon, have such oceans. Probes are on their way. There's a European probe called JUICE, which is on its way to explore Ganymede, swinging past Europa, and there's an American probe called Europa Clipper that will launch next year, arriving in 2030 and 2031 to explore these moons. Triton, Neptune's largest moon, may be another one of these icy worlds with an ocean inside. Even Pluto, which, by the way, definitely isn't a planet. We can talk about that later. Pluto may have an icy shell and an ocean within it. So it's not too far-fetched to imagine Pluto as a habitat for life. These places may be the most common habitats for life in the galaxy. So the idea of living on the surface of a planet, we may be the exceptions. And that if life is common, most of it may live in an ocean surrounded by an icy roof cut off from the rest of the system. And it's kind of interesting to think about what life might be like in such a world. You'd have no knowledge of the rest of the universe. You'd have no, if you managed to reach intelligence, I don't know, an intelligent dolphin in the middle of Europa or something, or squid or whatever. Maybe if you were good at physics, you'd deduce that you were in orbit around something. But I think dolphin astronauts emerging, having melted their way through the ice into the grandeur of our universe, are going to have, a shock, and B, are going to be very surprised to discover that life can exist on the surface of a planet this close to the sun and this exposed to the rest of the universe. There is a place, though, where we might get direct access to an ocean from one of these water worlds. And it's in a moon of Saturn called Enceladus, which was known to be a hugely reflective thing. This is it in the front here, with Titan, more of which in a sec, lurking in the background. Enceladus was this small moon, known to be made of water ice, imaged in passing by the Voyager spacecraft. It's about the size of the British Isles, nothing more than that. But when the Cassini probe went there and took close-up images, they showed these strange features. They're known as tiger stripes. They're sort of like glacial rifts scratched across the southern half of this moon. And again, no craters. So this is a fresh surface. But Enceladus attracted the attention of the mission planners when early on, Cassini having traveled for many years to get to Saturn, one of the first things it did, by coincidence, was fly near this moon. The cameras weren't turned on, most of the instruments weren't paying attention. But there was a group led by Michelle Doherty at Imperial College London, who were interested in magnetic fields in the system. They have this long magnetometer, a boom that sticks out from the spacecraft, and as it flies round, it records the strength of the magnetic field. And they were interested in doing all sorts of things with it, but they thought Enceladus would be a good test. They wanted to fly past Enceladus, and they expected to see no change whatsoever. Enceladus is too small to have a magnetic field, it should be inert. They flew past, their instrument worked fine, and they're excellent scientists, so they looked at the data and discovered that something had changed the magnetic field as they flew past. They didn't know what it was. They persuaded the team to fly back closer with cameras turned on, and they essentially flew their spacecraft through fountains of water that are shooting out from the South Pole. This is a real image of Enceladus taken on a subsequent pass. This is a water world. It somehow has a liquid ocean, which we know is salty because we've flown through it, which means that there's an ocean floor down there somewhere. And we think that life on Earth maybe got started on the deep ocean floor. So this is a habitat very much like the one that we came from. We also think that it might be long-lived. The water that escapes from Enceladus forms a tenuous ring around Saturn. It's called the E-ring. And this is Enceladus, the bright spot within the faint E-ring. And there's so much material there that we know that Enceladus has been active for millions of years. And so that means there's been an ocean there for at least millions of years. And so we have this idea that Enceladus may be the most likely habitat for life. And it's a place where if we go back with another spacecraft, you could take a sample just by flying through the fountains. We don't need to drill through the ice. We don't need to invent some elaborate technology. We can go and test whether there is indeed life in this moon just by flying past it. And of course, a visit back to the Saturnian system would be worth doing anyway. Saturn is, I think, indisputably the most beautiful of planets with the ring system around it. These millions, if not billions, of icy particles sculpted into this thin set of rings by the gravity of the planet and by the activity of shepherd moons, tiny moons which orbit around with the ring particles and keep them in place. The whole set of rings is about 20 meters thick, so much thinner than many of the buildings in the city around us are tall, and yet they provide this amazing, beautiful sight. But the other reason to go back to Saturn isn't the planet itself, though it's fascinating. And it's not the rings, even though studying them could teach us more about physics and dynamics. It's to go to a place called Titan, which I think is one of the most mysterious and interesting places anywhere in the cosmos. Titan, at first glance, doesn't look like much. Here it is seen from the Voyager probes, and it's an orange ball. And it looks like this because it has an atmosphere. It's the only moon in the solar system which has a thick atmosphere. It's an atmosphere like the Earth's that's mostly nitrogen, but it has hydrocarbon haze in it. That's why we can't see through it. You have to tune into the infrared to be able to see through this hazy atmosphere. Cassini could do that. Here's an early picture of the surface of Titan, seen darkly through the haze. You can see there are some indistinct features on the surface. But to find out what these were, we needed to send a probe down onto the surface. And Cassini dropped off a European probe called Huygens, which traveled down through the atmosphere and provided us with our first glimpse of the surface. So this is real footage sped up from that descent from the Huygens probe, sent back to Earth from the surface. And so, first of all, you go through the haze, but as we get deeper in, you can begin to see features emerging on the landscape, he said convincingly. It takes a little while to fall down. The moon's gravity is weak. But here you go. You can begin to see these are sort of look like river valleys. And that's exactly what they are. Titan is a place where it rains methane in great big methane raindrops the size of lawn tennis balls that fall slowly enough that you could dodge them if you were there because of the weak gravity. Titan is a place where instead of a water cycle, it has a hydrocarbon cycle. So these rivers are long-lived. They feed into oceans and lakes, which have all sorts of exotic things going on. There was a period where Cassini was seeing from orbit things called magic islands that seem to appear and disappear within the middle of these lakes. It turns out those are places where bubbles are coming up from chemistry that's happening under the surface. And Cassini was detecting a raft of bubbles that would then slowly disappear as the seasons change on this world. Huygens is still coming down here. There was no control. They just pointed it at Titan and hoped it would land somewhere interesting. It was equipped to land on liquid or on land. And in fact, it came down and bounced onto a frozen surface. And I might try and speed this up a bit. Let's go forwards. Because because I just want to show you the landing site, which has these frozen pebbles. So these are probably carbon dioxide or even hydrocarbon pebbles. There was a brilliant experiment where Cassini had a penetrometer, something that stuck out from the end of the probe. And the idea was that when it hit the surface, it could detect how hard the surface was so that we could work out what it was made of. They got quite a strange signal. They got a sudden jolt and then a second softer one. And they didn't really understand why this had happened. The principal investigator, John Zanecki from the Open University, in the press conference the next morning, having not slept, decided to tell the world that this felt like creme brulee, because you had a crust and then a soft landing. Rumours that John ended up dropping stuff into creme brulee in his lab, I can't confirm or deny. It's less like creme brulee. What actually happened was they hit one of these boulders, cracked it, and then slid off onto the surface. Titan is an amazing place. In these lakes, chemistry is happening. And the scientist Jonathan Lunine suggests that in those lakes, there may be something right on the edge of being life. Repeated patterns of chemistry, of complex chemistry that are self-perpetuating, but don't come anywhere near even the simplest virus or bacteria here on Earth. So Titan may be an edge case with lots to tell us. And I'm really excited that we're going back. In a few years' time, the Dragonfly mission, which is a little octocopter, will land on Titan. And the idea is that it will land in different places, study them for a couple of weeks, and then fly off and explore somewhere else. It's a completely new way of exploring a celestial body, and it looks really cool. So I'm very excited by Dragonfly. I want to end my tour of some of the marvels of the solar system by coming back to Mars, because it's easy to tell this story, and NASA and ESA and the rest of us do this all the time. It's easy to tell this story as a search for life, as a search for habitats, as a search for company out in the solar system. And discovering life elsewhere, especially if we could prove that it had started independently, would be one of the greatest scientific discoveries of all time. But I keep thinking back to an interview I did with Steve Squires, who is the principal investigator, the person in charge of the Spirit and Opportunity rovers that I talked about earlier. This is an image of Spirit looking back to a place called Husband Hill. You can see the tracks that this thing left on the surface. And I interviewed Steve about 2 years into his 90-day mission on Mars. And to give you a clue as to how he was feeling, I said, "How's it going?" He said, "We're tired." They were still at that point living on Mars time, which is 24.5-hour days, so they were slipping by half an hour compared to their friends, neighbors, and families, again and again and again as they went through the months. They eventually decided that they should let the rovers have a rest occasionally and they should stick to Earth time. But at this point, they discovered, as I told you, that water had once been common on Mars. But they'd found at that point, in the place where Spirit was, that it was acidic. To go back to the beginning, it was sort of about the same acidity as a lab bench sulfuric acid that you would have used in school or in a chemistry experiment. And so I just said casually, I said, "Oh, well, that's disappointing," because I was thinking about this story of trying to find places where our kind of life can exist. And Steve didn't quite lose his rag, but he got pretty annoyed with me. And I remember him saying, "The thing is, if you want to study an Earth-like world, you can stay on Earth. We go to Mars," he told me, "because it's like Mars, because it's not like Earth, because if we want to understand our solar system and our cosmos, we have to go to places that are very different. And the solar system is full of worlds that surprise us, from small asteroids like Bennu, visited by OSIRIS-REx just in the last few years, with a sample returned to Earth just a month or so ago. The swirling clouds in Juno's images of Jupiter are as beautiful as looking at Saturn's rings through a telescope. From up close, the rings and that dance of billions of particles has much to teach us. And Uranus and Neptune are the two planets which are closest to the most common type of planet in the Milky Way. And we've only seen them once from close up. And if Pluto, though it's not a planet, was the most interesting thing we'd seen when the New Horizons probe flew past and showed us mountains of water ice, heart-shaped features of churning material and all sorts of mysteries, then what are Eris and Makemake and the other hundreds of worlds of the Kuiper belt, the outer solar system, going to be like? The conclusion, I think, is that the solar system is full of marvels, and it doesn't matter that much if we don't have anyone to share them with. Thank you very much.
Chris, thank you. That was absolutely fascinating. I certainly felt that I learned an awful lot there. We've got time for a few questions. I'm going to start over here. And the first one is a nice, easy one to start you off with. And it picks up on that final point. How does this kind of research that you're doing challenge some of our normative or our conventional concepts of life, do you think?
Well, I think throughout we've been talking as if we need the same conditions that we have here on Earth. And when we talk about biosignatures and looking for places where life might exist, we implicitly mean places where our kind of life might exist. Now, it's possible that life can tolerate all sorts of things. On Earth, life tolerates all sorts of things. I think the biggest mystery of all is how life got started here. And we don't have any real idea of what conditions you need for life to get started. We think once it gets started, famously, it finds a way, right? So once life gets started, it can tolerate all sorts of things. But this is an exploration that tells us about whether and how life will have got started, thus how common it is in the cosmos. But I almost feel like the astronomers have done our job. We found this range of places. Now the biologists need to tell us which ones life can form in, and then we'll go and check.
So there's still, I mean, obviously we're moving away from those dreams of humanoid aliens and, Star Trek stuff.
Yeah, at least in the solar system, yeah.
So it's maybe sort of broadening our kind of concept or our inquiry about what life is or could be.
That's true. I think it also broadens our sense of, I think it's interesting. Look at those pictures of Mars, which, I do often. If you're lucky enough, if you go online at the right time, you could be the first person to see a new image of Mars as it comes down off the spacecraft, even before the team that built the spacecraft. But if you look at, Victoria Crater or something like that, it's very hard to me not to have a human response to this. Like, I think partly the rovers have cameras that are about this high off the ground, and so my head translates really easily to me standing there planning a walk. So I think it challenges us to imagine being in these places and how we'd interact with them as well.
Denise would like to know, is it correct that Jupiter and Saturn were closer to the Sun in an earlier solar system? And if so, what caused them to change orbits?
That is in my next lecture. Yeah. So we'll come back. But yes, so the spoiler is that the solar system is not the stable place it seems. And the interaction between the planets can do dramatic things, and we have evidence of that. So tune in January. I'm going to look straight down the camera. Tune in January to find out more about that.
Well, that would be a lovely link, but actually you've still got a few more minutes. So if there's any questions from the floor, please raise a hand.
What I want to ask you is, do all the planets have magnetic fields, or they don't? And also the other thing is that a planet like Jupiter takes a long time to go around the sun. Do they also spin round?
Yes,
as we do on Earth?
So yes, they all spin, though there are a couple of mysteries. Uranus rolls, so its poles are more or less pointed towards the sun, and so it rolls round. Venus, as maybe you know, spins very slowly. So a day on Venus is longer than a year. Which is going to make Venusian calendars very difficult. But we also don't understand why that should be so. So there's a generic thing in planetary astronomy, and apologies to planetary astronomers who are watching. If they can't explain anything, then they tend to just say there was a collision in the early solar system. So both Uranus and Venus's strange behavior has been explained by collisions. Magnetic fields, all the giant planets do, but not all the rocky planets. So Venus has a weak field, Mercury doesn't have one, and we don't understand why. One of the big mysteries of planetary science is why the Earth has a field and others don't. It may be linked to the fact Venus doesn't have plate tectonics. So our continents shift and change. That doesn't happen on Venus. Perhaps because the water has boiled away and there's no lubricant. But these are very different planets, even though on the surface, if all you know is size and mass, they appear very similar. So a big reason for doing more, and there are 3 probes planned to go to Venus in the next decade, is to try and see if we could predict why that's so different from Earth. And the magnetic field is clearly important for the atmosphere and presumably for the survival of life on the surface as well.
So we have another question from Slido, and this one's from Vicky. Do any other planets, any other than Earth, I presume, experience eclipses?
Oh, that's a really good question. Yeah, we have this marvelous thing that we get total eclipses of the sun. There's a great one in the States in April next year. If any of you are looking for somewhere to go to near the Mexican border. So that happens because from Earth, the moon and sun are about the same size in the sky. In other planets, you do see moons go in front of the sun. So we've observed this from Mars. The rovers have looked up and seen Phobos and Deimos, the moons of Mars, go across the sun. But they're much smaller than the sun, so it's more like a transit. Nowhere else has this coincidence. Now, I think it's coincidence. My colleague Steve Balbus thinks that that's the reason we're here on Earth, because the same effect that makes them about the same size in the sky means that the sun is also important in setting the tidal strength on Earth. So the moon controls the tides. The sun does the difference between spring and neap tides, very particularly dramatic. And that creates a range of environments that are sometimes but not always covered in water. And they could be left. So Steve's argument is that land-dwelling life took advantage of that opportunity, and therefore we should go looking for planets elsewhere in the galaxy that have moons the size so that will happen, and they're the places where we'll find our Star Trek aliens. The problem is we haven't found a single exomoon around another planet yet, but we're working on it.
I'm also being reminded that there were the Mysterons on Mars.
That's right, yeah, of course, but I'm not allowed to talk about them. Similarly, the clangers on the moon, I can't talk about.
And as for the man and the moon, well, we won't go there.
Loved your lecture, thank you very much. And you touched on this when you talked about maybe Russia now not contributing to a probe, was it going somewhere, I can't remember where, but also ethically, who do you think the universe and the solar system belongs to? And when you talk about, the race, whether it's scientists or billionaires or a combination of both, what are the rules, and should there be rules?
Well, there should be rules, I think. Obviously I should be in charge, and then we'll do some science. There is a rule that says that nothing in space can belong to any country. There's a UN treaty that says that. Whether that will hold up when people start traveling, I don't know. I think there's an environmentalism needed. Like Mars, especially if you take Steve Squire's point that Mars is beautiful because it's not Earth. I think we're at risk of turning it into Earth if the only people who go are billionaires who can afford to go. Or Elon Musk talks about colonialism and talks about people paying their way and going and living there and serving out time so they can pay for their flight. So I think we do need to think about this stuff carefully. For Mars in particular, I think the thing we should do first is go to Phobos, which is its nearest moon, get a brilliant view. You orbit Mars every few days, so you see the whole thing. You don't just have to go to one place on Mars. And from there, we could really study the surface. So if I was setting the rules, I'd do that first. And then when we're sure we understand whether there's life there, then maybe we can go and land. But if we ever go, I'm pretty sure it will be people with flags who want to get there first. And then it will more or less be a free-for-all, I think.
Thank you, and that's a timely, slightly frightening reminder of how close beauty and the quest for understanding can occasionally be to the will to possess. However, on that note, Chris, thank you so much. That was brilliant. Can you join me in thanking?
Thank you.